You ever stop and wonder how an AI can actually get a joke or, summarize a whole article or even write a poem? Well, it all boils down to this one truly revolutionary idea, teaching a computer not just what words are, but what they actually mean, especially in relation to each other. Okay, let's dive into this incredible journey from just simple words to something you might even call wisdom.
This old saying from linguistics, it's the key to, well, everything we're talking about. It basically means a word's meaning isn't some isolated thing. It's defined by the other words you find it with. You know, astronomy is about space because it's always hanging out with words like stars, planets, and galaxies. For decades, though, teaching a machine this simple, intuitive truth was just incredibly difficult.
And that really is the billion-dollar question, isn't it? How do you translate this beautiful idea about word friendships into the cold, hard logic of ones and zeros? The first attempt, well, let's just say it was a bit like trying to build a skyscraper with wooden blocks. So early on, engineers tried this method called one-hot encoding. The best way to think about it is like creating a massive, massive address book for every single word in a language. Here's how it worked, more or less. If your dictionary had, say, 50,000 words, then every word would be represented by a list of 50,000 numbers. This list would be all zeros, except for one single one marking that word's unique spot. It's basically a unique ID, a specific address for every single word. Just look at this table. The address for cat is just a 1 in a different spot than the address for dog or for king. Each word is on its own separate, totally isolated island of numbers. Now, looking at this, what can we possibly learn about their friendship, their connection, just by comparing these numerical addresses? And that's the punchline. Nothing. Mathematically, the vector for cat is just as far away from dog as it is from king or apple. It's like trying to figure out if two people are friends by looking at their house numbers. The numbers themselves tell you absolutely nothing about their relationship. This method just had no concept of meaning. So yeah, researchers needed a completely new approach. They had to get away from this simple address book and create something more like a map, a rich, multidimensional space where the position of a word actually told you something. And this right here shows that huge leap forward. We're going from a flat list of isolated words to this rich map where words that mean similar things are actually close neighbors. This new way of doing things is called word embeddings, and it is all about capturing those relationships between words.
Okay, so how does this actually work? Well, imagine for a second we could rate words on different features. For gender, man and king might get a positive score, woman gets a -1. King gets a really high score for royal status, and apple gets a high score for food. All of a sudden, their numerical profiles start to reflect what they mean. In the real world, an AI learns hundreds of these features all by itself, creating a really rich vector for every single word.
And get this, we can actually prove this closeness with math. We use something called cosine similarity, which, in simple terms, just measures the angle between two word vectors on this map. If the angle is tiny, the vectors are pointing in a similar direction, which means the words are semantically close. A score near 1, they're basically synonyms.
Right, so the crucial question is, how does the AI build this incredible map without us having to hand-label thousands of features? Simple. It does it by reading a lot, and it uses this brilliant technique called word-to-vec, which learns everything it needs to know just by looking at word neighbors in sentences. So, how does the AI learn? It plays two really clever games. The first one, on the left, is basically a fill-in-the-blank puzzle. The AI sees a bunch of words and has to guess the missing one in the middle. The second game, on the right, is the opposite. The AI gets one word and has to predict all the words that would be its neighbors. By playing these two games, literally millions and millions of times, the AI starts to figure out which words like to hang out together.
Okay, let's put it all together. This diagram shows the whole learning process in action. First, you have a sliding window that moves across a sentence. Second, it starts making pairs of words. Third, the AI tries to predict one from the other. And fourth, and this is the magic part, it adjusts its own internal numbers to get better at it next time. You do this over and over and over, and eventually the word vectors just sort of arrange themselves into that meaningful map.
And once that map is built, something that feels like magic starts to happen. The relationships between words become so clear, so well-defined, that you can actually start doing math with them. Let's walk through the most famous example of this. Okay, so imagine we're on our word map. First, we find the point, the vector that represents the word king. It's got coordinates that capture all these concepts, like royalty, masculinity, power, you name it. Now for the cool part, we do a little math. We take that king vector, and we literally subtract the vector for man. What does that do? It basically removes the masculinity part of the equation, leaving us with a new vector that represents the pure concept of royalty, the essence of what it means to be a monarch. So, to that abstract idea of royalty, we now add the vector for woman. We're essentially plugging the femininity component back into our equation. So what we have now is royalty plus woman.
And what we find is just astonishing. The final point we land on after doing this math is right next to the vector for the word queen. King minus man plus woman equals queen. The math, it actually works.
And this right here is the most profound takeaway. The AI hasn't just built a fancy dictionary, it has learned the abstract relationships between concepts, like the relationship between gender and royalty. It learned to understand an analogy.
So let's just quickly recap the big points from all this. The main idea is that context is everything. Old methods like one-hot encoding just couldn't get that. But word embeddings create a meaningful map where words are represented by these powerful vectors. On this map, distance equals similarity, and most impressively, this whole thing allows an AI to do logical feats, like solving analogies with math.
And that leaves us with a pretty fascinating thought to end on. We've seen how an AI can chart the incredibly complex connections within our language. So the real question now is, as this technology gets even better, what deeper patterns might it show us about the very structure of how we think? What can this map of our words really teach us about our entire world of ideas?